If we run it, we cannot run it. Why? Let's see. It's give us a problem. Why is that? Let's fix it. Not flip it. What is the problem? Yeah. No. Yeah.
I was thinking it should ending the program before it executes.
No. Yeah. Huh? Oh, okay. Okay, good. Semicolon after return. Okay. Very important.
Dream to land on the moon or colonize Mars? Then learn programming. This semester I'm teaching C++ at City University of New York. Watch my lecture to achieve your dreams.
CS172 C++ computer programming. This fall semester, our total course will be divided in 20 lectures. 20 lectures. Today's lecture is the lecture number 1, and the name of today's lecture is From Apple to Apple. This is the topic of today's lecture. My name is on the syllabus, but my name is Professor Rashdul Bari. My email address is rb3080@columbia.edu. Today's lecture will be divided in three parts. Part 1, what is computer? Part 2, what is computer programming? Part 3, C++. So we'll basically start C++ today. So what is computer? Let's ask ourselves, what is computer? Anybody? Yeah. Okay, what is the definition of computer?
The device could has applications on it that you can communicate through. It's a device.
Yeah.
Computer is a method that when we start anything, like whatever we want, like it's a method that we can find everything from online.
Okay, computer not Google. Is more than that. More than that. Yes.
Device that carries out our instructions that we program it to.
Okay, very nice.
It could be a calculator.
Oh, it can be a calculator, but it is more than a calculator. It used to be calculator when Charles Babbage invented it.
Right.
But now it is more than calculator.
Just a calculator, but the basic premise is that it's a device that we tell it this is what we want it to do, and then it carries out those
Right.
instructions.
Fantastic. Yeah, I think you want to add something.
I was going to say computer is a device that runs binary codes too.
Oh, fantastic. Binary code. Okay. Okay, binary code. Okay, very good. So we'll try to cover that as well. We'll try to a little bit talk about how computer kind of understand only the binary code, not whatever we say in English or other natural language. Okay, so computer is a device. So computer is a device that can be programmed to perform. That can be programmed to perform something very important I'm about to say. What do you think? Perform dash and dash. To perform dash and dash. To perform what? Yes.
Tasks, computations.
Logical and arithmetic. So computer is a device that can program to do logic and arithmetic performance on what? On data. But it must be, the task must to solve a computable problem. What is computable problem and what is not computable problem? Can someone give me an example? What is a computable problem and what is not a computable problem? Yes.
1 plus 1, 2 versus
A computable problem, 1 plus 1 is 2. He decided to give us a very simple example. but let's start with a very simple example. What is not computable?
It's how beautiful someone is.
Oh, how beautiful someone is, or is there any God? Computer cannot tell us whether is there any God or not. What is the biggest number computer can tell us? Because nobody knows what is the biggest number. If someone say infinity is the biggest number, then we don't understand the notion of infinity. How big the infinity is, nobody knows, because infinity plus infinity is equal to infinity. But 1 plus 1 is not equal to 1. So we don't understand the notion of infinity. So computer cannot give us what is the biggest number, for example. So computer can only do so much, not everything. Okay. All right, now data, when we talk about data, what type of data we are talking about? What is data? Data is information, right? How we kind of receive information. We receive information by, for example, reading New York Times or watching CNN. But computer cannot receive information by watching CNN or reading New York Times. It cannot read New York Times. So how can computer receive data? Ask yourself. And give me the answer. How can computer receive information as a data? Yeah. We enter the data. User input. We give the computer data. In a way, computer can translate it to the binary number, which is 0 and 1. But we are the one who give computer the data, the information, to do the calculation, to do the thinking. Someone said computer is a computing machine, but today computer is more than a computing machine. Computer used to be a computing machine. Now today computer is computing machine plus what? A thinking machine. But we never changed the name of computer. When Charles Babbage invented it, he named it computer because he invented computer to do what? To solve the math problem. When you talk about math, for example, what is the most important math? Calculus. And who invented calculus? Sir Isaac Newton. How did he invent it? So one day in 1640s, he was sitting under an apple tree. All of a sudden, he saw an apple fall. He looked at the sky. He saw a moon. He asked a simple question: if apple fall, does the moon also fall? That's why we named it apple to apple. In order to solve that falling moon problem, he invented calculus. And that calculus allowed him to solve the falling moon problem. But the calculus is not easy to solve. Some of the calculus problem, differential calculus problem, it takes days to solve it. And Charles Babbage was a smart guy. He thought, I cannot spend days and nights, I have something other things to do. So let's do something smart. Let's invent a machine that can do the calculation so that I can do other important thing. So he invented a computing machine. So Charles Babbage. 1840. Charles Babbage, the father of computer, by the way. At that time when he invented it, he named it computer is because it could only solve differential calculus problem. Is there anyone over here took the yes? Babbage, Charles Babbage. This is the last name. Babbage. Okay. So he invented it to solve a differential calculus problem. Just how many of you took the differential calculus? Raise hand. Calculus 1. Okay. So for example, differential calculus look like this. The very tiny one, the baby one is look like this. dy over dx is equal to, for example, cosine x. F of 0 is equal to minus 1. So you integrate it both sides. dy dx cosine x. Before you integrate it, you can make it a little easier. You can do cross multiplication. So dy is equal to cosine x dx. Now you integrate it. So dy is y. Cosine x, well, when you integrate cosine x, those of you who took calculus, you know that. Who took calculus? What is the integration of cosine x? Sin x, good. Sin x. However, you have to add c. Okay, those of you took calculus 2. Okay, so y become the negative 1. This has become 0. So sine of 0 is what? This is 0. Sine of 0 is 0, right? Okay, those of you who take trigonometry, sine of 0 is 0. So 0 plus c. So c is negative 1. So this is a Babbage differential equation. So why we are talking about differential equation in a computer science class is because computer was invented to solve differential equation, differential calculus problem. Like this one. Not like this one. This one with one variable, like the one with 100 variables. It takes days and nights to solve. You came late, right? You need syllabus and you need other things, but at the end of the class, not now. Okay. Now, so Charles Babbage invented the computer to do that. Now, next thing, we're going to talk about only 10 important days of the computer. 10 important things make computing machine to thinking machine. It should be named. If I was in power, I would name it thinking machine. Not a computer machine. It's not a computer machine anymore. It's more than that. It's a thinking machine. But for historical reason, we're not going to change the name. Okay, so now the William Thomson. William Thomson, 30 years later, 1870, analog computer, invented analog computer. Computer. Number 3, MIT invented Then the biggest thing happened. The biggest thing in computer science, the Turing machine. So Alan Turing. So this is the computer. Alan Turing. Alan Turing invented Turing machine. So what happened around 1918? David Hilbert, one of the biggest mathematicians of all time, he wrote a math problem because he is considered as the father of modern mathematics. If Newton is the father of physics, he is the father of modern mathematics. David Hilbert. He wrote a problem. Is there any machine anybody can invent using math which can give us a decision in yes or no? That's it. Is there any way you can use the math to invent a machine that can give us a decision in form of what? Yes or no? Is there any God? Yes or no? Okay. And it was too difficult for people, but it wasn't so difficult for this guy, Alan Turing. He invented Turing machine, and that revolutionized the computer industry. There was no computer industry at that time. Only scientists and mathematicians were using the computer. So there was no computer industry, and the military used the computer at that time. So as small as it was, it revolutionized. So people started thinking that, is there any way we can use the computer to solve all the problem, everything, including is there any God type of problem? So that we put the data in the computer and computer say, no, there is no God. Let's be happy, there is no God. Okay, or there is a God. Even nowadays, today, computer cannot give us solve that type of problem. Okay. So Alan Turing, he made it a computer machine to a thinking machine. Okay. So after Alan Turing is the Harvard Mark I computer. It was invented to use during the World War II. So 1948, 47, toward the end of World War II. Harvard Mark I. And then the transistor was invented. and then the microprocessor. And then the first computer language, Fortran. Fortran. The first computer language was written, Fortran. Number 9, integrated circuit. And then number 10, I told you I'll tell you the 10 important events of computer. Guess, who can guess the 10, the last one? I promise you to tell you.
Storage.
The apple to apple. Look at the title of our lecture. Apple computer. Apple 1. Apple 1. So from apple to apple, why we call it apple to apple? So the apple is connected to the invention of calculus. So Newton unlocked the mystery of the universe when he saw apple fall, and he invented calculus to solve the falling moon problem. That's the apple. This apple made the computer universal. There was no computer industry before 1976. 1976, Apple I came to the market 1976. Before 1976, computer was used by only few people. Who you think computer was used by before 1976? Only scientists, mathematicians, not even engineers. Well, big scientists, all the military people. Only few people had access to computers. A big university like, for example, Harvard had only one computer lab, and people had to kind of put their name on the waiting list to use that computer. One computer was like from here to like end of the year college is small college, like so big the machine is. So they had like only few computer, a few university, and lucky student get to use it or get to see it. So that computer became a household from the science and the math and the military people to everyone else like you and me. 1976. So 1840 to 1976. This is the brief history of the computer. Now we're gonna literally talk about the computer language and the C++. Anybody want to tell me what is the computer language? Before computer language, someone said binary or something. Who said that? Binary computer only understand the binary code. Who said that?
I said that.
You said that, binary code. Let's touch on that a few seconds. So the computer, if you look inside the computer, if you, even before that, computer can be divided into two types. Can someone tell me two types of computer? Two types of computer. Computer that we use and computer we don't use. So classical computer. So classical computer. And then what do you think? Can someone tell me? Quantum computers. Classical computer use the bit. Someone said binary bit or something. Classical computer use the bit. Quantum computer use what? What quantum computer? When you talk about computer use bit, what actually you talk about? When we look at the computer, Turing machine, the computer we see is a Turing machine, and we know the Turing machine, right? Turing machine is a computing machine or is a thinking machine? It's both. It can think. It can give you the decision. All right. So bit. This one is qubit. So when we talk about the computer, we talk about like inside the computer, what happened? You have the memory, you have the CPU, and you have what? Input, output. Input, output device. So CPU, when we talk about the CPU, we actually talk about two things. Logic gate, and what else? The math.
Binary.
The arithmetic. It can perform only 4 different arithmetics to make the decisions. So arithmetics. What is it? Plus, minus, multiplication,
Division.
and division. Okay. So logic gate and the arithmetics. Okay. So now, for example, the bit. What is bit?
Data.
Bit is the data that come in different size. Let's say 1 bit. What is the 1 bit? How do you write 1 bit? 1 bit is what? 1 bit. So one bit is what? Anybody? 0 and 1. Is that okay? So computer use the binary numbers. What do we use? We use what? A decimal numbers.
Yeah.
Computer use the binary numbers 0 and 1. We use the decimal numbers. So what do we use? When we talk about decimal numbers, what do we use? What are we talking about?
Base 10.
Base 10. 0, 1, 2, 3, 4, 5, 2, what? 9. So we use the decimal numbers. Computer use binary numbers. You probably think that why then the computer do not run out of numbers? Use only 0 and 1. So how can it calculate so much thing and make some, when we type something on Google, it gives us information so fast, 0 and 1. Why it do not run out? Well, we using only 26 letters in English, right? If you are a writer, will you think that you will ever run out of letters to write a good storybook? You will probably never run out of letters. Okay, so you can use that analogy. Computer will never run out of numbers, even though it use the binary numbers. Okay, so binary numbers only 0 and 1. So 1 bit is what? Can someone tell me?
It's 1, 1.
0 and 1, right. 0 is what? What is 0? By definition, 0 is off and 1 is on. 0 is off, 1 is on. We got it? So then what is the 2 bit? What is the 2 bit?
Is it the same thing?
0, 1, 0, 0, 0, 1. Tell me. Go ahead. 0, 0, 0, 1, 1, 0, and what? How many possibilities? 0, 0, 0, 1, 1, 0, and one more. 1, 1. All right. Do this one with me. Help me out. 3 bit.
0, 0, 0.
Okay, sure. 0, 0, 0,
0, 0, 1.
0, 1, 0. Okay.
0, 0, 1.
0, 0, 1. Okay.
1, 0, 0.
All the way. Last one. Tell me the last one.
1, 1, 1.
1, 1, 1. Okay. Someone added 1 plus 1 for me. Who that? Who gave me 1 plus 1 is 2. That computer can do that. Compute. Okay. All right. So can we add the binary? All right. So binary to decimal. Convert the binary 101 to decimal. Go ahead. Convert the binary 101 to decimal. How can we do that? We write 2 to 0, 2 to 1, 2 to 2, 2 to 3, and so on. We write 1, 0, 1, 1, 0, 1. We don't have any more, so we don't need to use that. Okay, now we're gonna come over here. 2 raised to 0 is what? By definition, 2 raised to 0 is what? 1. 1 times 1 is 1. Plus 2 raised to 1 by definition is what? 2. 2 times 1 is 2 times 0 is 0. 2 raised to 2 is by 4. 4 times 1 is 4. So 101 is what in decimal? 5. 101 is 5. All right, now I'm going to give you 20. I'm gonna ask you to work backward. 22 binary. Go ahead. Write 22 binary. Give you 1 minute. Right? Okay, let's do it together. 20, right? What is the biggest power of 2 in 20? What is the biggest power of 2 in 20? Because binary means something raised to what? 10. Binary. Something raised to 2. 2 is 0 and 1. All right. So what is the biggest power in 2 in 20? Is 2 raised to 4 is too big, or 2 raised to 5 is too big? 2 raised to 5 is too big, because 2 raised to 5 is what? 32. That's not what we have. So what is the biggest power of 2 in 20? 2 raised to 4, right? So 2 raised to 4 is what? 16. So we write 1, we write 16. All right. So 16 plus what is 20? 4 to go. 4 more to go. 4. What is the biggest power possible to write 4? We found it. Because that's 20. And we're going to close our eye and we're going to put some what? Zeros. And that's it. And then we're going to come over here and we're going to write what?
1 0 1 0 0.
It's not too difficult. Okay. Now I'm going to give you 1 minute. First I want you to add these two numbers because I know you know how to add these two. Okay. But add these two numbers. Okay. So you can write 1 0 1 0 0 and 1 0 1. Add them up. Let's see. 1 0. Now 2. Okay. So what is this? What I wrote? Okay, let's see. What is this? 5 plus 20 is what?
25.
Hopefully 25. Now let's see what is this. Maybe this look like too much binary. So we put it in machine. Let's see what machine gives us. 1 0 0 1 and then 1. Okay, let's see. Let's do the same thing. 1 times 1 is 1 plus 2 times 0 is
0.
plus 4 times 0 is
0.
plus 8 times 1 is
8.
and now you tell me
16.
16. Now let's see whether we can add that. 25 and the check. So if we can convert it, then computer must be able to convert it. So what is computer converting? What are we talking about when computer converting? We don't tell computer, I need a coffee right now, because the computer will not understand that. So we have to write what? Yes.
Question.
Yeah.
You had the one on one top of each other, right?
Yeah.
So since it can go to 2, so that one carries over.
Yes, that carries over. Very good. Good point. Carries over. Okay. Good thinking. You can, yeah. So that one carries over. Okay. Now, so I want to write 5. I want to know 5 plus 20 is what. So I cannot say computer, hey computer, 5 plus 20 is what. So in order to communicate with computer, what I have to tell it? I have to go to the compiler and I have to write what? The way computer understand it. The way computer understand it, and there are many ways you can write it. Fortran is one of the way. The computer language that invented the fast computer language. But in this course, what are we going to be typing it in? C++. So we can write it in C++ that, hey, we want to add 5 plus 20 in C++. And then the computer will do what? If we write program in C++ 5 plus 20, then compiler will do what? The compiler will do what? Convert it to binary, and then in machine language, so machine understand that, and machine gives you what? 25. And it happens how fast? Very fast. It happens very fast. Okay. Now, the logic gate. Logic gate. So this is logic gate and arithmetic. So it can do operations on the data. It can do performance on the data using the logic gate and plus, minus, multiplication, and division. So okay, so the logic gate. Let's see, A, B, A and B, A, not and B, complement. So this is the truth table which we use to create the logic gate. Where is the logic gate, by the way? Where is it located in the computer? CPU. The two main thing in the CPU, logic gate and what? The arithmetic. So it used the Boolean algebra to do the logic gate. So this is the Boolean algebra. We're gonna create the logic gate for A and B, and A, not and B. So 0, 0, 1, 1. 0 means off. So off. So the logic gate would be like what? The logic gate would be this would be what? A. This would be B. If A is 0, B is 0, then A and B would be 0. Complement of that would be 1. Is that okay? So let's draw complement. Complement, you put a little circle. Complement. So if A is 0, B is 0, what is A and B? 0. So instead of 0, I'll just put A and B general. If A is 0, B is 0, what would be the complement? 1. So I'm gonna write A and B, not. A, not, and B. What about this one? Off, on. How many people think it is on? If it is 1, raise hand. 3, 4, 5. Okay, so 0 and 1 is 0. Oh no, it's not adding. It's the truth table. This is called truth table. What would be the complement? 1. 1 and 0? 0. What would be the complement? 1 and 1? And what would be the complement? 0. So this is the logic gate, simplest logic gate. This is the truth table using the Boolean algebra. That's how the computer convert programming C++ to what? To binary code. The code computer understand in terms of what? 0, 1, 0, 1, 0, 1, so on. Okay, now, so that's the computer programming. That's what the computer programming. Now, usually people start with the programming class with hello world. So I'm gonna give you a few minutes to write the hello world in C++. So 3 minutes. Everyone go. Write C++ hello world in C++. However, this time you have to help me out. If I write effort instead of effort, if I write college instead of college, if I write colon instead of second colon, raise hand and shout out. Yeah. Oh no, do it next time, okay? I'm gonna do it here. Okay, All right, so what would be the first thing we're going to be doing? Help me with the first line. Huh? Call the library. Oh, no. Tell me the code. Tell me the code. Pound. Okay. What include? Okay, so what are we gonna do now? From the library, right? So how do we do that? Name it using. How do I know using or user? Let's see when I write user, what happened? Like MS Word, like it tells me you fix it. What am I gonna do? Semicolon. Okay, so what is the line of the code we have to write? INT. We have to write body. Okay, so let's see where is the body. Well, body is what? It starts with what? Curly braces. Okay, inside the body is something else. We have to command it what we want the computer to do. Count. Count means character out. The string. Oh yeah, we don't. Oh, hello world. Oh yeah, sure. Why? It doesn't belong question mark. It belongs like X. Yeah, it doesn't. Yeah, we don't have to do. Inside the string, you can put anything. You can put in name. And end of the line. So you're gonna have to write end of the line. End of the line. Now we have to do what? Huh? All is well. Oh, it doesn't really matter. Okay, now I'm gonna save, and I'm not gonna save it. Yeah. Return 0 is you have to. Oh, return 0 is inside. Okay. If we run it, we cannot run it. Why? Let's see. It's give us a problem. Why is that? Let's fix it. Not flip it. What is the problem? Yeah. No. Yeah.
I was thinking that you're ending the program before you execute it.
No. Yeah. Huh? Oh, okay. Okay, good. Semicolon after return. Okay, very important thing. Okay, hello world. Yes.
When you use count, you have to use end line. When you use count, you have to use end line as it's closing the count.
Right. Okay, so this is our hello world first program in C++.
Subscribe to Bari Science Lab to fall in love with math and science, especially programming.